Alright, everybody, welcome back. Today I'm doing the chapter 38, Diffraction Patterns and Polarization from the 9th edition of the Survey and Jowett. Alright, before we start, I do want to show you something. On my channel, in the playlist section, you can take a look at this, which is the optics playlist. You could see the first video here, Waves, Optics, and Modern Physics. The overview is a big overview of the entire curriculum of the semester. All of the videos here are the 7-minute summaries for each of the optics chapters. And what you see on the screen currently is the final chapter 38 7-minute summary for the optics section. So this will complete the 7-minute summaries for optics. This is a type of studying that I like to think about as big overview first, and then specialization in the areas where you struggle at. Classic 7-minute summary always starts with setting a timer for 7 minutes.
All right. I created a 7-minute timer.
Alrighty, and we are off. We have 6 sections: Introduction to Diffraction Patterns from narrow slits, resolution of single slit and circular apertures, the diffraction grating, diffraction of X-rays by crystals, polarization of light waves. We will begin with a couple of sentences. When a plane light wave passes through a small aperture in an opaque barrier, the aperture acts as if it were a point source of light, with waves entering the shadow region behind the barrier. This phenomenon is known as diffraction. It was first mentioned in section 35.3 and can be described only with a wave model for light. In this chapter, we investigate the features of the diffraction pattern that occurs when light from aperture is allowed to fall upon a screen. Alrighty, let's take a look at just some pictures, because that whole sentence took probably half a minute. And we have, okay, this is very strange looking. I'm assuming this is a little diffraction pattern they're talking about. And take a look at this. Opaque object, kind of like a piece of wood or a piece of paper, it looks like a matchstick, and a light source behind it creates this kind of striped pattern of light. I honestly don't believe that. I haven't seen that too much before, and that is called a diffraction pattern. I'm reading the bold words here. It says central maxima, side maxima, secondary maxima, minima. Notice the bright spot at the center. Alrighty, that's section 38.1. I guess a small introduction. Here we have diffraction patterns from narrow slits, Fraunhofer diffraction pattern. Okay, looks like a young double slit, but with a single opening. And this creates an interesting looking pattern here on the viewing screen. We have a pitfall prevention. I cannot read it, but I'm going to notice the word diffraction is in there many times. We have Young's double slit experiment here, except with multiple openings. Not too sure. Some sign equations with lambda. Condition for destructive interference for a single slit. This equation looks very similar to what I saw in the previous chapter, chapter 37. So I'm just going to keep that in mind. We have an example, first example of the chapter. Where are the dark fringes? I'm assuming this helps us find these dark fringes in the pattern here, probably using a couple of these sign equations, which are just introduced. We have, let me see the timer, 4 minutes, 22 seconds. Intensity of a single slit diffraction pattern. Okay, I've seen something like this before. Intensity equation. Normally I remember it with a cosine squared inside, but now it looks like we have a sine, a bunch of stuff inside the sine, a division symbol, and a square. But we do have that I and I max, which stands for intensity of a double slit Fraunhofer diffraction pattern. Fraunhofer, okay. That guy's name is being mentioned multiple times. We have another equation, condition for intensity minima for a single slit. Okay, another subsection, intensity of a two-slit diffraction pattern. Here is that cosine squared equation, and look at this. This is a very interesting looking function. Who would guess that this function in the red over here, which is describing this interference pattern, is the same as this crazy looking function with the cosine squared and all this other sine squared stuff? All right, we'll explore this more deeply, but that is a cool looking equation. I'm just going to keep that in the back of my mind. Nice. This is a cool looking pattern as well. It basically looks like this pattern here, except with like little beats inside of each of those big fringes. That looks kind of complicated, but we're gonna just keep moving forward. A couple more sine equations. A quick quiz with, oh my goodness, A, B, C, D, E, F, G, H, I. Damn, how many sections is that? This is a thick quiz. We cannot read it right now because we have only 2 minutes 50 seconds for this entire chapter. 38.3 resolution of a single slit and circular aperture. Let's read this yellowed out section here. When the central maximum of a one image falls on the first minimum of another image, the images are said to be just resolved. This limiting condition of resolution is known as Rayleigh's criterion. I'm not too sure what that means, but it looks like this picture here may be talking about it. The angle subtended by the sources at the slit is large enough for the diffraction patterns to be distinguishable. Okay, very cool. And then for the B section, the angle subtended by the sources is so small that their diffraction patterns overlap and the images are not well resolved. Okay, so this is kind of what resolution means, if you can tell two different diffraction patterns apart, I'm assuming. Here we have something else. It looks like in A, you can distinguish those two sources. In B, they kind of combine a bit. And in C, they're pretty much the same point source. I'm not sure what that means, and I'm not too sure. Okay, limiting angle of resolution for a circular aperture. I guess this is important. Let's take a look at, we have a couple more quick quizzes. And the resolution of the eye. I've actually always thought about this. Resolution of the eye, I guess here we use those equations to solve for that. I've also always thought about resolution of an eagle's eye. I'm assuming eagles can see like tiny leaves and stuff from really high up. So resolution of an eagle, or example 38.3, resolution of a telescope would also be a cool problem to do. And they do it in the book over there. Let's take a look at the timer. 1 minute and 3 seconds of the diffraction grating. A useful device for analyzing light sources consists of a large number of equally spaced parallel slits, a transmission gradient. Okay, we can't read all of that. Yellowed out equation, condition for interference maxima for a grating. Whoa, that is a diffraction grating here. It is actually labeled and it does all of this crazy stuff. Looks like multiple young double slits together. Another big quick quiz. A compact disc is a diffraction grating. That is a crazy sentence. Worthy of a tattoo. The orders of a diffraction grating, okay. Application of diffraction gratings. Let's see the timer, 28 seconds. Oh my goodness, more applications. Let's take a look at this. Chess. I like chess, but I don't know how it's related to this. Diffraction of X-rays by crystals. This is crazy. What is this? Okay, I'm gonna keep that in mind because I like crystals. Polarization of light waves. Oh man. Okay, interesting. Polarization of by reflection. Polarization by double refraction. Oh my god. Polarization by light scattering. Optical. Damn. Okay, that was rough at the end. Optical activity and the summary. Wow, okay. These 7-minute summaries are actually painful, but they are my first run-throughs, except the previous chapter, of what the chapter looks like. And it's very nice to do. And now that we've done this, we can look back at the curriculum overall and see that we've covered every single chapter for the light and optics section. Now that we've covered everything, we can just deep dive into each of those chapters and do some problems, iron out confusions, figure out curiosities, answer questions about the chapter, and we can write stuff down, put it on post-it notes, put that post-it note on your bathroom mirror. Every time you brush your teeth, look at that, read it, and just keep trying to refresh your memory about the important equations, important concepts of each chapter. And by the time an exam comes, you will be booling. I hope you guys enjoyed this. Take a look at some of my other videos about all of the 7-minute summaries. And soon I will do a bit more slower read-throughs of the previous chapters and some more problems as well. Thank you guys for watching, as always. And stay hydrated. Call a friend. Talk about some physics concepts if you wish. And I will see you guys in the next video. Peace.